All right, today's lesson is on 1.7, completing the square, and this is part 1 of this lesson. The main thing about this lesson is you're going to be referred to, or I will be talking about, a perfect square trinomial. So before we get started, I want to explain to you what a perfect square trinomial is. You've dealt with these before, you just don't really realize what they were called. Okay, all three of these are perfect examples of a perfect square trinomial. When you factor these, it results in two binomials that are identical. For example, if you're looking for two numbers that you would multiply together to get 1, but add together to get 2, your factor would come out to be x plus 1 times x plus 1. Now, because both of those parentheses are the same, you would actually write it as x plus 1 all squared. And because of that, you're able to square root both sides and all that fun stuff. So you're looking for the end result is a perfect square. So you're always looking for something here that's a perfect square. And then the middle is the sum of the two numbers that you squared. So what two numbers would you square to get 4? You would square 2 and 2. So your factoring comes out to x and 2 and x and 2. But here's the trick to this one. When they add together, they have to be positive 4. So that would be positive 2 and positive 2. So x plus 2 times x plus 2, and the resulting would be x plus 2 all squared. Now this next one's just a little bit different because this one is plus and plus, this one is plus and plus, this one is minus and plus. However, it's the same idea. Two numbers you would multiply together to get 9. It's a perfect square, so it would be 3 and 3. And then you're going to put your x here and your x here. But when you add them together, you get negative 6. So it would be negative 3 and negative 3. Because remember, negative 3 times negative 3 is a positive 9. So characteristics of a perfect square trinomial is that this is always the positive of some type of square root, whatever it might be. So this would become x minus 3 all squared. And you might not quite understand that, but you will as you get through these. It's one of those ones that just takes a little practice. Let's look at example A. Example 1. Solve a quadratic equation by finding square roots. Okay, we're still solving a quadratic equation. We've learned to solve them by factoring. You've learned to solve by finding square roots. You're going to be solved by quadratic equation soon. So there's so many different ways to solve it. But this one can be solved by finding square roots because look, that's a perfect square. How do you get 16? You get 4 times 4, so that's a perfect square. So step 1, write the original equation. All right. Now, how do you get 16? It's 4 times 4. But then what those 4s would have to be what in order to them to be negative? They would have to be negative 4 because negative 4 plus negative 4 would give you negative 8. And negative 4 times negative 4 would give you positive 16. So the side is a binomial squared. You would say x minus 4 squared equals 25. Now you're going to take the square root of both sides. And now you have x minus 4 equals positive or negative 5. Now guys, this is where that positive and negative becomes important. Because you still have to solve for x. You're going to have to get a value of x. But what you realize is a positive and a negative. That means x minus 4 can equal positive 5. And x minus 4 can equal negative 5. So it actually becomes two different problems. So x minus 4 equals positive 5. Or x minus 4 equals negative 5. And you're going to solve for x. So on this side you would add 4 to both sides. And over here you would add 4. But this answer would result in x equals negative 1. So you are solving this answer out, but now you're getting two different solutions. So you get x equals 9 and x equals negative 1. And if you took those and plugged those back in here, then they would work. Also, if you were to graph this would actually be the x. Drew the graph, not that I'm asking you to, but when you drew the parabola, it would intercept at a positive 9 and a negative 1. So your parabola would like open up and intercept there. It just tells you they're called the zeros. All right, now let's take a look at B. Now you might be looking and go, Ms. Hurd, it's the same thing, but it's not. What's different here? This one is negative 8x. This one is positive 8x. So that means the factoring is going to be different. So you're looking for two numbers that you would multiply together to give you 4. but add together to give you said that wrong. Two numbers multiplied together to give you 16, but add together to give you a positive 8. So this one is actually going to be x plus 4 all squared equals 25. You're still going to square root both sides, and you're going to get x plus 4 equals positive and negative 5. Now see what you got up here? Here you had minus 4. Here you have plus 4. So then at this point it becomes two different problems. So x plus 4 equals 5, and x plus 4 equals negative 5. And you're going to subtract 4 from both sides. X equals 1, and you're going to subtract 4 from both sides, and x is going to equal negative 9. So the solutions for this will be 1 and negative 9. Okay, now let's go down here to example C. Now, if you'll notice this one has something out front. So this is one of those A times C, so your C equals 4, but B equals 4. Well, you might be saying, Ms. Hurd, that's 2 again. You're right, but remember the last numbers, this is where the trick comes into play. If you were to come up with two binomials, and you were to multiply the last times the last, they would still have to equal 1. So the only way to multiply two numbers to get 1 would be 1 and 1. But we need, wait a minute, we need to make it 4. And remember, our parentheses have to look the same. So it's actually going to be 2x plus 1 and 2x plus 1. Now, I want to tell you, you can do the box. You can do the box method. You know, if you want to go ahead and do the factoring, and those of you who struggle with it, that's fine. So you're looking for two numbers you would multiply together to get 4, but add together to get 4. Oh, that's 2 and 2. So remember the box method? 4x squared here, 1 here, 2x here, and 2x here. Now you're going to pull your GCF out of here. The GCF of 4 and 2 is 2. The GCF of x squared and x is x. The GCF of 2 and 1 is 1. They don't have an x in common. So see, there's your 2x plus 1. Then when you go this direction, you're going to get 2x and 1. So there's your two pairs right there. Now you have 2x plus 1 all squared equals 75. All right, so then what are you going to do? You're going to square root both sides, and you're going to get 2x plus 1 equals the square root of 75. Now, if you recall, you change it to a decimal, whatever that might be, but remember, you want a simplified radical form. So how do we break down 75? You're going to go 3 and 25 and 5 and 5. So now, and I'm going to have to go up here because of space purposes, now we have 2x plus 1 equals positive or negative, we have a pair of 5, so it gets to come out 5 square roots of 3. Now, because I have two problems here, you're going to split this into two problems. 2x plus 1 equals positive 5 square roots of 3, and 2x plus 1 equals negative 5 square roots of 3. Okay? You're going to subtract 1, and you're going to subtract 1. Well, guys, rules for radicals is when you add and subtract radicals, they're the same rules for variables. Square roots of 3 can combine with square roots of 3. So since those are totally different, at this point you have 2x equals negative 1 plus 5 square roots of 3. See, those can't combine. Now you're going to divide everything by 2, and x is going to equal negative 1 plus 5 square roots of 3 all over 2. Now you're going to go up here. That's one of your answers. Now you're going to go up here and you're going to do the same thing. You're going to subtract 1. You're going to subtract 1. So at this point, you're going to have 2x equals negative 1 minus 5 square roots of 3. You're going to divide by 2. So you're going to have x equals negative 1 minus 5 square roots of 3 all over 2. And that's your final answer. You always want to have a simplified radical and specify differently, or based on the answer, it will tell you what you need to know. All right, now we're going to go on to your turn. Go ahead and do number 1. Pause it for a moment. All right. You know that this is a perfect square trinomial because 4 times 4 is 16 and 4 plus 4 is 8. So this is going to factor to t plus 4 all squared equals 45. Now we're going to square both sides, square root, excuse me. Okay, so now that leaves me with t plus 4 on the left, and then we need to simplify this. Well, that's 5 and 9, and then 9 breaks down to 3 and 3. So 3 square roots of 5. Remember, it's plus or minus. So because you have a plus or minus, that gives you two different problems. So you're going to have t plus 4 equals positive 3 square roots of 5. You want to put the plus in front, you can. T plus 4 equals negative 3 square roots of 5. Subtract 4 from both sides. Because this is a square root of 5 and this is 9. So t equals negative 4 plus 3 square roots of 5. So that's one of your answers. And then here, you're going to do minus 4 and minus 4. So same process. T equals negative 4 minus 3 square roots of 5. And there are your two solutions. Okay? All right, go on to number 2. Pause it for a minute. When you're ready, go ahead and hit play. All right. Now this is one where there's an A and a C. So A times C equals 36. And B equals negative 12. So you're looking for two numbers that you would multiply together to get 36, but add together to give you negative 12. Those two numbers are going to be negative 6 and negative 6. Guys, when you're dealing with a perfect square trinomial, those two numbers will always be the same. Now, you might want to go ahead and do the box just because it's a little bit harder when there's bigger numbers out front, and sometimes I don't even trust my brain depending on the day and the time. So 9x in the middle, last term here. Split that middle term. All right, you're looking for a GCF. GCF of 9 and 6 is 3. X squared and x is x. Negative 6 and 4. Remember, it's whatever you take out here is the sign of this box. So this is going to be negative 2. Go this direction. This should be 3x. This should also be negative 2 because remember you want them to be the same. So then you're going to have 3x minus 2 all squared equals negative 3. Now what do you notice? You're going to take the square root of both sides. However, this is a negative. That means you have an I. Yes, this one's a little trickier. It's one of those ones I throw in there. Those of you that can do it, do it. Those of you that don't can follow the directions. So what you have at this point is you have 3x minus 2 equals the square root of negative 3. Simplify this. This becomes 3x minus 2 equals positive or negative I root 3. Because remember, when you bring that negative out, it turns into an I. Now, two different problems. You have 3x minus 2 equals positive I root 3, and 3x minus 2 equals negative I square roots of 3. Add 2. So now we have 3x equals 2 plus I square roots of 3. Because you can't combine them, divide both sides by 3. So you're going to get x equals 2 plus I square roots of 3 all over 3. Add 2 and add 2. 3x equals 2 minus I root 3. Divide everything by 3. And x is going to equal 2 minus I square roots of 3 all over 3. Now, because they're the same, if you wanted to write 2 plus minus square root of 3 all over 3, oop, I forgot my I, you can. These two answers or that together, that just puts these two answers together. So there's your final answer. All right. Now let's down here, making a perfect square trinomial. It's actually very simple, but there's like almost like a chant if you and you'll hear me say it as I do the examples for you. Look at the original equation. It says find the value of c right here that makes x squared plus 16x plus trinomial. Now you need to make sure you understand this because if you don't, the next section is going to be a little. Now instead of a c, I'm going to put a little line here, but that is your c. That's what you're replacing. All right. Now it says step 2, divide by b. Will you bring down? Because I always say 16 divided by 2 equals 8. So divide by 2. There's my b. I divided it by 2. Square the number you got. When we divided by 2, we got 8. So we're going to square it, and that equals 64. And write it right there. So what it becomes is x squared plus 16x plus 64 is the value of c that would make this a perfect square trinomial. Positive 16. Okay. So E. Bring down B, 16. Divide that by 2. Okay, I just did that one. Okay, I don't know why I just did the same problem, so ignore that one, sorry. All right, bring down B, negative 13. Notice I'm saying negative 13. You're going to divide that by 2. Yes, it's going to give you a decimal. Okay, so negative 6.5. But the rules don't change. You're going to do negative 6.5, and then you're going to square this. So you're going to do negative 6.5, and you're going to square it, which is going to give you 42.25, and that's what's actually going to go on the end here. So the answer to this would be x squared minus 13x plus 42.25. Okay, and just for the record, that number you get right there, right before you square it, that's actually what this perfect square would be if you factored it, because it would be like x minus 6.5 squared. Okay, that's just something to put in the back of your head because you're going to want to know that when we get to the next part. Not on these notes, but the next notes. All right, so same situation. Bring down B. Divide it by 2. It's going to give you negative 4.5. Square it. Add it to the end. So 2.25, that replaces C. So you're going to get x squared minus 9x plus 20.25. And that's the value that would make of C that would make it become a perfect square trinomial. Okay, here this is again. I don't know why I keep coming up with all these, and if it wasn't for the fact that I'm right at the end of the notes, I would retype it. I didn't catch it. So I know what we'll do. Why don't we go ahead, instead of a 16x, let's go ahead and change this. Let's make this x squared plus, let's do 20x plus C. All right, go ahead and pause your video and do that one. All right, if you did this correctly, you would have brought down 20. You would have divided it by 2, which would have given you 10. Then you would have squared it, and that would have given you 100. So 100 is the value of C that would make this a perfect square trinomial. So the perfect square trinomial would be 20x plus 100. All right, so actually the only thing they're looking for is that. All right, and last but not least, let's go ahead and do number 4. Pause your video. All right, so you're going to take your middle term, which is 11, okay, positive 11. You're going to divide that by 2, and that's going to give you a positive 5.5. You're going to square that, and if you square that, that will be 30.25. Now, guys, the answer, based on the directions they give you, they say find the value of C that makes it a perfect square trinomial. That would be that. All right, but basically what the perfect square trinomial you're talking about would be, and little trick, again, a little bit ahead of time, and those of you who are actually watching this video, it'll help you. If I asked you to factor this trinomial, that right there would do. It's a positive 5.5, so this would actually factor to this. Trust me when I tell you that little tidbit of information will make the next part of this section a lot easier. All right, I hope you understood that. If not, don't worry. As long as you watch the notes, you have a little bit of idea of what's going on, and then when you come into class, I will be happy to help you.